Hello all, welcome to Engineering World. So today we are going to discuss important DSA topics that are asked in an interview. So these are the 12 important topics which are included in the data structures and algorithms. So one who want to become a software engineer, they has to know data structures and algorithms. The most product based companies will ask data structures and algorithms. If you want a high package, then you must learn data structures and algorithm. So firstly, these are the 12 important topics which are very it's mostly included in the data structures and algorithms. The first one is arrays. Arrays is nothing but what? It's a linear data structure that collects elements of the same data type and stores them in a continuous and adjacent memory locations. It means what? It can store a similar data types in a continuous memory location. Arrays is of two types. First one is of int array of tree. It means what? It is of single dimensional array. And second one is multi-dimensional array, which is in the form of matrix. So these are the two types of arrays. Second important topic, that is strings in a data structure. String is nothing but what? It is a sequence of characters. So string can be terminated using a null character. So this is the second important data structure algorithm topic. Coming to the recursion. Recursion is nothing but what? The function which calls itself is nothing but a recursion. Okay, so the process of recursion involves solving a problem, so by turning it into a smaller varieties of itself. It means the recursion in stack in data structures, and the functions can be called directly or indirectly, so that is recursion. So next we have sorting. Sorting is nothing but what? The arrangement of a data in a preferred order is called sorting in data structures. So by sorting, it is easier to search through it quickly and easily. The simplest example of sorting is dictionary. Okay, and the sorting algorithms are many algorithms we have. So first we have insertion, and we have bubble sort, and we also have selection sort. So these are the some sorting algorithms which are included. And coming to the linked list. So linked list is also important data structure algorithm. It is the most important data structure where it comes to handling the dynamic data elements. The linked list is used to handle a dynamic data elements. It means dynamic elements. And so a linked list contains a data element which contains a node. Okay, and each node contains a two fields. One field has data, and in the second field the node has an address that keeps a reference to the next node. So it contains a two nodes. So firstly, the first node contains what? The nodes is equals to 2. So the nodes are 2. The first node contains data, and second node will contain address. So this is nothing but a linked list. Coming to the stack. What is stack here? Stack in a data structures is a linear type of data structure that will follow LIFO principle. LIFO stands for last in first out. So this is a principle which is followed by the stack, and it allows insertion and deletion. Two operations we can perform here. First is insertion and second one is deletion. So in the stack data structure. Coming to the queue. Queue can be defined as a order list. It means which enables insert operations to be performed at one end called rear and delete operations to be performed at another end called front. So there are two terms which we are including, rear and front. Okay, and queue is referred to be as first in first out. It means it follows a FIFO principle, whereas stack follows LIFO principle and queue follows FIFO principle. So this is about queue. Next, coming to the binary search. The binary search in a data structure and algorithm is very important. So this search algorithm will work on the divide and conquer method. So we have divide and conquer method. So the data collection should be in the sorted form, and binary search looks for a particular item by comparing the middlemost item of the collection. So we are going to compare with a mid value. So mid value is equals to what here? So mid value is equals to start plus start plus n divided by 2. So you have to compare the mid value with a search value. Next, we have hashing. Hashing is a data structure. It is a technique of mapping a large chunk of data into a small tables using a hashing function. And it is also known as message digest function. It is a technique that uniquely identifies a specific item from a collection of similar items. So in this it contains a hashing function, and also we are going to map. So mapping can be done. So mapping of a large chunk of data into a small tables. So that is nothing but hashing. And 10th one is graph. So graph, you already know, the graph contains vertices and edges. Okay. So this graph is also very important data structure algorithm. And coming to the trees. Tree data structure is a hierarchical structure that is used to represent and organize the data in a way that it is used easy to navigate and search. So it is going to organize the data. Okay. So it is going to organize data, and it is a collection of nodes so that are connected by edges, and there is a relationship between the nodes. So it is a collection of nodes. Trees is a collection of nodes, and also there is a relationship between the nodes. So that is nothing but a trees. Coming to the dynamic programming. So dynamic programming is used where we have problems like which can be divided into similar sub problems, okay, so that the results can be reused. So this is called a dynamic programming. It means a problem is divided into a small parts, and whatever the results we are getting, so that can be reused. So that is dynamic programming. And mostly these algorithms like dynamic programming algorithms are used for optimization purpose, and also we are using it in a dynamic way. So this is a way we are going to use a dynamic programming. It means before solving in-hand sub-problem, dynamic algorithm will try to examine the results of the previously solved sub-problems. So we are actually dividing a problem into a sub-problems. Whatever the results we are getting, again we are going to reuse. That is dynamic programming. And it is mainly solving for optimization purpose. So these are the important data structures and algorithm topics. So the one who want to become a software engineer, they has to know these topics. The first one is arrays, strings. Third one is recursion, sorting, linked list, stack, queue, binary search, hashing, graph, trees, dynamic programming. So I hope you understood this video. So thank you for watching my video, and we'll meet in the next video with a different topic in an engineering world. Bye.